Welcome, this is a video over 3 notes, and this is about slopes of lines. And the first thing I want to talk about when we're talking about slopes of lines is that these are slopes of lines, let's write slope, and that's a measure of steepness. Okay, so we can actually figure out how steep something is and apply a numeric value to that, which is pretty powerful. So the one thing I want to talk about here is the types of slopes that we get when we have parallel lines and perpendicular lines. So the first thing I want to do is talk about parallel lines. And I know that these lines have the same slope. Okay, so what I would do to draw an example for you, let's just say we have a line like this and a line like this. We know that they're parallel. I'll call this line M, and this is line L. And so if I wanted to show that they're parallel, let's just say that, I don't want to use, I'm not going to use M. Okay, let me cross that off. Let's call that just N, okay? If we know that they're parallel, we have this notation here with the arrows that show that they're parallel. And I can also write that N is not equal to, is parallel to line L, okay? But then let's say that the slope here of this line would equal 2. Then if these are parallel, then the slope of this line, M, would also equal 2, okay? Now, the next thing I want to talk about are perpendicular lines, and these are lines that intersect at at right angles. Okay. And so what I can do here is if I were to draw, say, parallel or perpendicular lines, okay, I'd have these two lines here and here. I'm going to call this line S. Okay, call this line T. And these intersect and they form a 90-degree angle here, okay? And so if I were to say, you know, line S is perpendicular, okay, this is my symbol for perpendicular, an upside down T. S is perpendicular to T, okay? And then what I know here is that the slopes are opposite reciprocals, okay? And I'll talk about that. Opposite reciprocal, okay? So let's just say that this had a slope of, say, 2, that this slope here is M is equal to 2. Then this slope would have to be M is equal to -1/2, okay, if that was the case, okay? And so when I talk about opposite reciprocals, that means that we flip the fraction, okay, and we change the sign. Okay, so notice how if this is 2, this is really just 2 over 1. And so what I've done is I've flipped the fraction here and made this negative, okay, and this is positive, all right? So now I do want to talk about the slope formula, and we've all gone over this in class. We've been kind of doing this all year. But I want to say that given 2 points, so given 2 points, say x sub 1 and y sub 1, x sub 2 and y sub 2, I can calculate their slope by doing m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, this we should really have memorized. You'll always be able to use the graphical method, and we've been doing that graphical method all year long. But, you know, these are you know, the notes that we need to have, okay, and we can use this, all right? So let's just take a look at numbers 1 and 2. It says determine the slope of the line that contains those given points. So the first thing I'm going to do, given something like this, and number 1, is I'm going to identify that this is the point x sub 1 and this is y sub 1. I'm going to call this x sub 2 and this is y sub 2. So using our formula that we have, I know that my slope m is equal to 4 minus 2, okay, over 0 minus negative 1, okay? And even if it's negative, we go ahead and just plug it in as negative. We still want to subtract it. All right, so then we get this. Then we get 4 minus 2, which is 2, and then 0 minus negative 1 is really just 0 plus 1, so that's going to give us 2 over 1. So our slope is equal to 2 here, okay? We've been doing this for a while, all right? Let's take a look at number 2, and this is... gives us the point negative 2, 5, and 1, negative 7. First thing I'm going to do, I'm going to call this x sub 1, y sub 1, call this x sub 2, and y sub 2. And so my slope m is equal to negative 7 minus 5, okay, divided by 1 minus negative 2, all right? And so this gives us negative 7 minus 5 is going to give us negative 12. And then 1 minus negative 2 is really 1 plus 2. So we get negative 12 over 3. Okay, now we can simplify this number. Okay, negative 12 divided by 3 actually simplifies to m equals negative 4. Okay, and so that's our slope between those 2 points. Okay, again, you can do this graphically, and that's fine as well. Okay, so let's go ahead and... take a look at numbers 3 and 4, okay? And in number 3, we want to determine whether line AB and line MN are, whether they're parallel, whether they're perpendicular, or neither. Okay, so we have to take a look at the slopes on those. All right, so let's go ahead and let me zoom in on number 3. And I'm going to go ahead and call let me name this first point for AB as x sub 1 and y sub 1, and this is x sub 2 and y sub 2. So my slope here, m, is equal to, say, negative 7 minus 3 divided by 5 minus 0, okay? And this is going to give me negative 10, okay, over positive 5. So my slope here is equal to negative 2, all right? Those simplify down to negative 2. All right, and let's go ahead and find the slope for mn. Okay, this is x sub 1, this is y sub 1, this is x sub 2, y sub 2. So we have to do this twice. So my slope here is m equals negative 1, negative 1 minus 7 divided by negative 2 minus negative 6, so negative 2 minus negative 6. So that's going to give us negative 8 up top, okay, divided by, and this becomes negative 2 plus 6. So we get m is equal to negative 8 over, what is that, positive 4, okay? And so this one simplifies down to m equals negative 2, okay? So because these are the same, okay, because they're the same, we know that these lines are parallel. So if I wanted to show that and write that, then I would write this. I would say that line AB, okay, line AB is parallel to line MN, okay? So, but I have to look at their slopes, and because they're the same, then we know that they're parallel, okay? All right, let's take a look at number 4. Let's see what happens when we get those. And so number 4, I'm going to do the same thing that we did. Okay. I'm going to go ahead and call this x sub 1 and y sub 1, and call this x sub 2 and y sub 2. So our slope m is equal to negative 5 minus 4. Okay, negative 5 minus 4 divided by 2 minus negative 1. So divided by 2 minus negative 1. So we end up getting this. We end up getting negative 9 divided by positive 3. Okay, I got that by doing 2 plus 1. So my slope is equal to negative 9 over 3. So my slope is equal to negative 3. All right. Okay, now let's take a look at line MN. okay? And I'm going to call this x sub 1 and this y sub 1, call this x sub 2 and y sub 2, okay? And so mn, I'm going to get that slope by plugging in my values into my formula, so I get 0 minus 2 divided by 3 minus negative 3, okay? And so that's going to give me negative 2 divided by positive 3 plus 3, so positive 6. So I'm going to get slope is equal to negative 2 over positive 6. So this ends up giving me negative 1/3. Okay. Now you may think that these are opposite reciprocals when you flip the fraction and change the sign, but these are both negative. Okay. So since they're both negative, they're not opposite. Okay. So these would be neither parallel or perpendicular. These are neither. These are just intersecting lines. Okay, neither. AB, line AB just intersects line MN. Okay, and so that's all we get. If they were, so I want to write this. Okay, if they're perpendicular, then you know, if the first slope we got was negative 3, then the perpendicular slope would be m is equal to positive 1/3, okay? So, you know, because they're both negative, then, you know, they're not going to be perpendicular, okay? So hopefully that's reasonable for you, okay? Let's take a look at 5 and 6, okay? And this is asking me to graph the line that satisfies each condition here. And so the first thing I want to do is that I know I have a point A on my graph. So A has the value of 0, 1. So I'm going to plot a point here. Okay, and our slope is 3. So since m is equal to 3, all right, then I know that I can rewrite that as 3 over 1. And this is my rise, and this is my run. Okay, so I'm going to go up 1, 2, 3. Wait, no. 1, 2, 3, and over 1 and plot a point. Okay, I can also go down 1, 2, 3, and over 1 and plot a point as well. And I can go down 1, 2, 3, and over 1 and plot a point. Okay, and I know that this is my slope here, and that's positive. Okay, let's take a look at number 6. All right, and I know that the slope, okay, we have the point R, which is negative 4, 5. So 1, 2, 3, 4, up 1, 2, 3, 4, 5 is right here. Okay, and we have a slope of negative 3 over 2. So my slope m is equal to negative 3 over 2. So this is my rise, and this is my run. So we go down 3. So 1, 2, 3, and over 2. 1, 2. I'm going to plot a point here. Okay, I'm going to go down 1, 2, 3, and over 2. Plot a point there. Go down 1, 2, 3, and over 2, and plot it there. Okay, so as a result, I'm going to connect those dots, and we get a line. All right, and that's it. Now, I want to quickly talk about something that really isn't touched upon much in here, but I'm going to talk about the direction that slopes go in, and this is something that I draw on the top of my paper at all times if I'm talking about slope. And this is, slope can be positive if it's going in this direction. Okay, the slope is negative if it's going in this direction. The slope is 0 if it's going horizontally, and if you have a vertical line, then this is undefined. Okay, so, you know, make sure you have that written down. We've been talking about this for a while, so this is kind of a review, but I hope you enjoyed this video. I really had a good time making it, so I enjoy slope. Slope is fun. We get to do it with fractions, and you all know, friends, that fractions are my true friends, okay? That and Pythagoras. All right, see ya. Bye.